Hello, my graduate students, welcome to you. Now I shall start my class repeatedly reduction formula of integration and beta-gamma functions. Now you follow my class attentively and continuously. The problems and solutions are very successful for your exams, different exams of academics and competitive exams. Now I start. Number 1, 0 to 1, x to the power 2p minus 1 log 1 plus x dx equal to prove that 1 by 2p 3 into 4 and last 2p minus 1. Now by logarithm series, Taylor series, we know that 0, 1, x to the power 2p minus 1, logarithm series x minus x square by 2, x cube by 3 minus x4 by 4, and so on. Zero to 1 x to the power 2p half 0 to 1 x to the power 2p plus 1 1 by 3 0 to 1 x to the power 2p plus 2 and so on. Now by mathematical symbol by 1 0 to 1 dx x to the power 2p plus 1 by 1 by 2p plus 1 half x to the power 2p plus 2 2p x to the power 2p plus 2 by 2p plus 2 1 by 3 x to the power 2p plus 3 by 2p plus 3 and so on. 0 to 1. 1 by 2p plus 1 1 by 2 2p plus 2 1 by 3 2p plus 3 minus and so on. Now Now it is represented by mathematical symbol summation r 1 to infinite minus 1 whole to the power r plus 1 by r 2p plus r. That means when we putting r equal to 1, we obtain this, r equal to 2, we obtain this mathematical expression 3, this. So it is represented by mathematical expression. Now summation r 1 to infinite 1 by r minus 1 whole to the power r plus 1 minus 1 by 2p plus r by 1 by 2p. Now on simplification we have 2p by r into 2p plus r, and 2p and 2p is here vanish. No problem, very interesting matter here. 1 by 2p minus 1 whole to the power r plus 1 summation of r 1 to infinite 1 by r minus 1 by 2p summation r 1 to infinite 1 by 2p plus r minus 1 whole to the power r plus 1. Now 1 by 2p, it is breaking to two parts. Now firstly r1 to 2p minus 1 whole to the power r plus 1 by r. Next breaking r 2p plus 1 1 to infinite minus 1 whole to the power r plus 1 by r minus 1 by 2p summation r 1 to infinite minus 1 whole to the power r plus 1 by 2p plus r. This is very interesting matter. Breaking two portion, it is equal to this portion. Now putting r equal to 2p plus 1. So this is 1 by 2p plus 1. This is minus 1 by 2p into 2p plus 1. So when r equal to 2, r equal to 2p plus 2, r equal to 2p plus 3, and this portion and this portion will be vanished. Now finally 1 by 2p, first you put r1 2p plus 1. This and this is and r1 1. This and these are equal. When r1 2p plus 2, this is 1 by 2p plus 2, r equal to 2p plus 2, then minus 1 by 2p plus 2, r equal to 2p plus 2, then plus 1 by 2p into 2p plus 2, here 1 by 2p into 2p plus 2. So this is vanished. When r equal to 2p plus 3, this is also vanished. When r equal to 2p plus 4. So final result will be 1 by 2p r1 to 2p minus 1 whole to the power r plus 1 by r. That means 1 by 2p 1 by 1, 1 by 2 plus 1 by 3 minus 1 by 4, 1 by 2p minus 1 minus 1 by 2p. So 1 by 2p, 1 into 2, 3 into 4, and the last term will be 1 by 2p, 2p minus 1. Next question, when this question may be in other way, that prove that this question may be in other way, that x to the power 2p minus 1 log of 2p plus 1 log of 1 plus x, and this is variable, then you can be solved by this method. Now next question will be number 2, 0 to infinite sin mx x square plus a square. These questions not only by mathematical reduction, not only the B.Sc general pass by honors standard, these may be solved by the differentiation method. Here we know that here x is variable, but when we differentiation of the integration, then differentiate with respect to m or a. Here m we let we or suppose that m here then vary, but all the other terms must be constant, keeping, and when we a is vary, then the other terms will be constant. What is the value of this? Number 1, let I equal to 0 to infinite sin mx x, number 1. Number 2, 3, 0 to infinite cos mx by x square plus a square dx. What is the value? X square plus a square dx. Now integrating and now differentiating with respect to m. Here suppose that m is vary, but all the terms must be constant here. Now di dm 0 to infinite, 0 to infinite. Now x cos mx by x square plus a square dx. Second time derivatives, 2 times differentiating with respect to m, we have 0 to infinite minus x sin mx x square plus a square dx. Now Multiplying x to both sides, up and down, we have d square I dm square minus 0 to infinite x square sin mx x square plus a square dx. So minus 0 to infinite x square minus a square plus a square minus a square by x into x square plus a square dx. That means 0 to infinite sin mx by x dx plus a square 0 to infinite sin mx x square plus a square dx. We know that before the class, we know when m greater equal 0, then it will be minus pi by 2 plus a square I, because this is, we suppose this is I first. Now this will be d square I dm square. So d square I dm square minus pi by 2 plus a square I d square I dm square minus a square I plus pi by 2 equal to 0. d square I dm square minus a square I minus pi by 2a square. Let t equal to I minus pi by 2a square. Obviously d square t dm square. Here I and t are two variable quantities. So d square I dm square, putting the values, d square t dm square minus a square t equal to 0. Now we write that t equal to I minus pi by 2a square. So t equal to, by solution method, c1 e to the power am plus c2 e to the power minus am. This will be solution of the differential equation. Now when m, putting the values of t, I minus pi by 2 a square equal to c1 e to the power am, c2 e to the power minus am. When m equal to 0, firstly I 0 to infinite sin mx x square plus a square. When m equal to 0, I equal to 0, obviously. So putting the values I 0 equal to C1 plus C2 minus plus pi by 2 square. C1 plus C2 equal to minus pi by 2 square. Next, DIDM. Again, DIDM 0 to infinite cos mx by x square plus a square dx. So DIDM now differentiating with respect to m of this equation 1. So DIDM a into C1 e to the power am minus a into C2 e to the power minus am. When m equal to 0, again putting DIDM 0 to infinite cos mx x square plus a square dx equal to, when m equal to 0, putting m equal to 0. So 1 by m integration 0 to infinite dx by x square plus a square. So 1 by a tan inverse x by a. So pi by 2a. Again dm equal to this. So a c1 e to the power am m equal to 0. M equal to 0, that means a into C1 minus a into C2. Putting m equal to 0 here. So C1 am C2 e to the power minus m 0, C1 minus C2 equal to pi by 2a. C1 minus C2 equal to pi by 2 square. So this is number equation A and this is number equation B. Obviously, solving of these equations, we have C1 and C2. Now C1 plus C2 equal to minus pi by 2a square. C1 minus C2 equal to pi by 2a square. Adding C1 equal to 0 or C2 equal to minus pi by 2a square. So putting equation 1, I equal to pi by 2a square plus C1, that means 0, C2, that means minus pi by 2a square, into pi by 2 square plus e to the power minus am. This is the integration of 0 to pi sin mx x by x square plus a square, obviously. And DIDM, what is the value DIDM? Very easy. DIDM means C1 m e to the power am minus C2 a into e to the power minus am. So here C1 equal to 0 and C2 equal to minus pi by 2 square. DIDM, that means C2 value, putting the values of C2 pi by 2 square e to the power minus am. So finally the integration 0 to pi sin mx x square a square dx, again integration 0 to infinite cos mx dx by x square plus a square. So here limit will be 0 to infinite to both cases. So finally we can be obtain the integrations of 0 to infinite sin mx by x square plus a square dx, 0 to infinite cos mx by x square plus a square dx. Now finished this problem. Second problems will be in minus 2n 0 to pi by 2 cos 2n minus 2x sin nx dx 1 by n minus 1. Prove this. Now this is absolutely reduction by reduction formula. Suppose that this is the first function and this is second function. Now cos to the power n minus 2x 0 to pi by 2 sin nx dx minus n minus 2 cos to the power n minus 3x sin nx integration plus minus cos nx by n dx minus cos nx cos to the power n minus 2x by n 0 to pi by 2. Next, n minus 2 by n cos to the power n minus 3x sin x cos nx 0 to pi by 2. 0 to pi by 2. Now putting pi by 2 will be 0 and second time putting 0. So 1 by n minus n minus 2 by n cos to the power n minus 3x into cos x sin x. Now sin x cos nx, we know the basic formula sin n minus 1x equal to sin nx cos x cos nx sin x. Sin x cos nx, sin x, putting the values of sin x cos nx, sin x cos nx equal to sin nx cos x minus n minus 1x. Obviously, putting the values, sin nx cos x minus sin n minus 1 x. So this will be I n minus 2n 1 by n, n minus 2 by n cos n minus 2x sin x, that means I n minus 2n, multiplying this, multiplying cos n minus 2x into sin x, which is the given of the question, second, plus n minus 2 by n I n minus 3 n minus 1. So transposing I n minus 2n 1 plus n minus 2 by n 1 by n n minus 2 by n I n minus 3 n minus 1. So I n minus 2 n 2 n minus 2 by n 1 by n n minus 2 by n I n minus 3 n minus 1. I n minus 2 n 1 by 2 n minus 1 n minus 2 2n minus 1 I n minus 3 n minus 1. So similarly, I n minus 3 n minus 1 and n minus 2n, that means 1 by 2 n minus 1 n minus 2 by 2 n minus 1 I n minus 3 n minus 1 means replacing by n minus 1, replacing 1 by 2 n minus 1 minus 1 n minus 2 n minus 3 2 n minus 2 I n minus 4 n minus 2. Obviously I n minus 2 n 1 by 2 n minus 1 1 by 2 n minus 1 n minus 3 by, that means n minus 3, putting n minus 2, n minus 2, 2 into n minus 1, I n minus 4, n minus 2. So, I n minus 2 n, now taking the step jump, 1 by n minus 1, 1 by 2, 1 by 2 square, 1 by 2 to the power n minus 2, 1 by 2 to the power n minus 2, I 0 2. Now putting the I 0 2, what is the formula? I 0 2. Now I n minus 2 n equal to cos to the power n minus 2x sin nx dx. Putting n equal to 2. So 0 2, 0 to 1, 0 to pi by 2 sin 2x dx, 0 to pi by 2. Now cos 2x by 2, 0 to pi by 2. That means pi by 2, pi by 2, that means pi minus 1 cos 0 minus half minus 1. So 1. So finally the result will be this is 1. So n minus 2n, 1 by n minus 1, 1 by 2, 1 by 2 square, 1 by 2 to the power n minus 2 plus 1 by 2 to the power n minus 2. That means 1 by n minus 1 half 1 minus 2 to the power n minus 2, 1 minus half. That means plus 1 by 2 to the power n minus 2. This is vanished, so 1 by n minus 1. Now, these problems are honors standard, so not only some very short lines, and if you follow my classes, I shall give continuously for different chapters of B.Sc honors and B.Tech for long days. If you long times attentively follow, I hope that you must be success in your life. Lastly, I am telling to you, you share, subscribe to all your friends, and not only the academic exams, you must be help the competitive exams of India. Now finished here.